Okay, guys, I made a mistake yesterday. Yep. Yeah, touched something incorrectly. Let's just revisit this problem one more time. It's very small piece. Okay. Remember when we wanted to decide which one of these was the original? What did we look at? The zeros, and we saw that the blue graph crosses 0 right here. Is there any other graph? Is there a graph that has a derivative of 0 at 1? No, so we know that this can't be a derivative. Whereas if you look at the red one crosses right here, and the blue has a derivative of 0 at that same spot. So we agreed with that, right? So we said that the blue one was definitely going to be f of x, and we said that the red one was going to be f prime of x. Now, so this is the second piece I want to show you, and this is where I made a small mistake, and again I apologize. So look at the red graph. So now we're going to take the derivative of that. Derivative is always positive or always negative. So it's always going to be above the x-axis or always below. Above. So it has to be which? The blue, green, or I'm sorry, the purple, green, or yellow. Either the purple or the green, right? So let's just try this now real quick, okay? So if you look at this graph right here, okay, and you were to then make an estimation for the derivative. Let's say that this red one, let's say right here at 1, okay? Whoa. I thought I oriented it. Quick do this. No, it was, I was having some problems when my smartboard thing popped up. It was definitely not working. Would everybody agree that that is approximately a tangent line for the red graph at an x value of 1? What would you approximate that slope to be? About 1. If you look at it, over 1 and up 1. So, which graph has a value of 1 at 1? The green one or the purple one? The green. And so the green one happens to be f double prime of x. And so if you do estimate the derivative, I talked about looking which one was steeper and which spot, and that's just a bad way to do it. Okay, you should actually, try to represent some tangent marks, and looking at one, that's a good spot to look at it. So that's definitely a good idea there. So. And from there, obviously, you know then that the derivative of the green graph is always negative, so that's going to be f triple prime is going to be the yellow, and then obviously the last one left is going to be f quadruple prime. So, and if you did the same type of argument, you would see that it in fact works. If you plot this point right here and draw the slope. So here's my final argument. Here's where I saw I made a mistake. I drew tangent lines at x equals 1, which has a steeper slope. The yellow one or the red one? The yellow one has a steeper slope there, okay? And so you can then pair it up appropriately with the purple or the green accordingly. So, my bad. Sorry. Do you forgive me? All right. Okay, let's do the last example then. Sure. So, very nice. We're going to talk about motion now and how it applies to derivatives. The position function is s, And so the velocity function, v of t, is equal to s prime. If you take the first derivative, you get the rate of change, which happens to be the velocity function. Because we measure velocity in, say, meters per second. But acceleration is in meters per second squared. Okay? This is the second derivative. Acceleration in terms of t is equal to s double prime. Jerk would be triple prime. I'll be honest, I don't really see this. Your book does use this notation in some places. I guess we'll call it j of t is equal to s triple prime. I'm not going to use it in the example problem, but the book does bring up that terminology. It would come up in a physics class. In this class, we will limit it to velocity and acceleration. We will not discuss jerk. So it says the equation of motion is given for a particle where s is in meters per second, or s is in meters, t is in seconds. Find the velocity function, the acceleration at t, and the acceleration when the velocity of 0. This is not going to be too difficult. You guys can all do it. I'm going to list my 3 functions. Somebody give me the velocity function. Okay. And can you give me the acceleration function? Very good. What's that? Well, right. So we'll do. So we did part A. We did the velocity function. Velocity of t is equal to 3t squared minus 12t plus 12. Now we'll do part B. The acceleration at time 1. How do we do that? Plug in 1. And I get acceleration at time 1 is equal to 6 times 1 minus 12. I think that's the label. Meters per second per second. If you did meters per second, you would multiply by the reciprocal and you get the s squared on the bottom. So, and then C, it says the acceleration when the velocity is 0. What do I need to do first? Find the velocity when it's equal to 0. So what I have here is I need to take 0 equals, I'll factor out a 3. I get t squared minus 4t plus 4. Does that factor? Yeah, t minus 2 quantity squared. At time equals 2, the velocity is 0. What does that mean? Zach brings up a really good point here. Ultimately, he's incorrect. But so Zach sees that the velocity is equal to 0 at time equals 2. What do you notice? How many solutions are there at 2? It's a double. If you were to graph this, velocity function, 3 times t plus or t minus 2 quantity squared, that's a parabola that's shifted to the right how many units? 2. In fact, it has a vertex of 2, 0. Does that graph ever go below the x-axis? So is the particle ever going in the negative direction? No, it slows down and stops, but immediately starts going in the positive direction again is what happens. That's what happens when you have a double root often, is that type of behavior. So now we have that. We only have one time when the velocity is 0. The question is, what is the acceleration with the velocity equal to 0? It's not always going to be that way, but yes. So we say a of 2 is equal to 6 times 2 minus 12, which is 0 meters per second squared. That's not always the case, okay? The distance is in meters, time is in seconds, so our first rate of change will be meters per second. And so that's just the general label. Position will be meters, velocity will be meters per second, and acceleration will be meters per second squared. And that will just always be the labels. Yep, exactly. I think so, yeah. So, okay, very good. Here's your assignment. Yep.